on to question 3 then. So we've got binomial expansion. In this question, we should assume that x is between 1 and -1. For that binomial expansion, we want to find and simplify the first 4 terms. So this is a year 2 binomial expansion because we've got that negative power. So we can always go back and look and see what the formula sheet says. So binomial series, we've got 1 plus x to the n is 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1, all the rest of them over r factorial x to the r. So we'll use that. So we have got part 1. We have got 1 minus x to the minus 2 is 1 plus nx plus n minus 1 over 2 factorial plus n minus 1 n minus 2 over 3 factorial. Oops, I've forgotten x squared, and I've got an x cubed. Let's pop some terms in then. So I've got 1 plus n is minus 2, and that's minus x plus minus 2 minus 3 over 2 factorial minus x squared. Minus 2 minus 3 minus 4 over 3 factorial minus x cubed. Again, let's let the calculator do the heavy lifting, so I want to be in normal mode. And we have got 1, well that's dead easy, I can do that one, plus minus 2 times minus x, well that's plus 2x. Then I have got minus 2 minus 3 over 2 factorial. Factorial is, where's factorial gone? Factorial's there. And then I've got minus 1 to the power 2. So that gives me plus 3 x squared. And then I've got plus, I want to do the next one, so probably guess already what it's going to be, but we'll just double check. So 3, we want minus 4, and we want to change that to a power 3. So we have 4x. And that's going on forever. Write down the term in x to the n. So x to the n is n plus 1 x to the n, because when I had regular x, so x to the 1, I had a 2 in front of it, x squared, I had a 3 in front of it, x cubed, I had a 4 in front of it. When I had x to the 0, I had a 1 in front of it. So my coefficient is 1 more than my power. Write down the sum to infinity of the series 1 plus x squared plus x cubed, blah, 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 blah. So sum to infinity, we know this is a geometric. So we have got a is 1, and my common ratio, each of those is being multiplied by x each time. My sum to infinity, let's just double check what that is, so we make sure that we are happy with that. Sum to infinity is this one at the bottom, a over 1 minus r, so let's do that. So sum to infinity is a over 1 minus r, which is 1 over 1 minus x. I can see where this is going. So, hence or otherwise, find and simplify an expression for 2 plus 3x plus 4x squared plus 5x cubed in the form a minus x over b minus x squared, where a and b are constants to be determined. So let's have a look then. Hence, that probably means we're going to use what we need already. So what have we got? This is part C, a minus x over b minus x squared. First thing I'm going to think about is, so we've got that. We've also got 2 plus 3x plus 4x squared plus 5x cubed plus that, which is, that's n plus 2 lots of x to the n. So that's very similar to what I had before. So what could we do? We could, well, what about if we said this was, why don't we take away that 1 minus x all squared from that? Let's see what happens then. So that's not very helpful, but if I do 2 plus 3x plus 4x squared plus 5x cubed, and I take away, so we don't want any of that, that's not useful to us, and I take away that thing we had in the first one, so I take away 1 plus 2x plus 3x squared plus 4x cubed and all the rest, that's going to give me, well, 2 take 1 is 1, 3x take 2x is x, 4x squared minus 3x squared is x squared, and x cubed. Okay, so that means then that this sequence that we were given, so if we go back to thinking about our given sequence, that means then that 2 plus 3x plus 4x squared plus 5x cubed and all the rest of it is equal to 1 plus x plus x squared plus x cubed plus plus the sequence we started with, which is 1 plus 2x plus 3x squared plus 4x cubed plus all the rest of it. Now, what did we know about that? Well, this 1 plus x squared plus x cubed, that was a sum to the thing we did in the first place. So the sum to infinity, all of this adds up to be 1 over 1 minus x, because we did that in the sum to infinity bit, plus the 1 plus 2x plus 3x squared plus 4x cubed and the rest of it, that's the sequence we did in the very first part. That's your 1 minus x to the minus 2. So that is 1 over, I've lost it again, 1 minus x to the minus 2. So that's 1 over 1 minus x squared. That was that sequence. Now we have something that we can add up. So I want common denominators of 1 minus x squared. So that means the left-hand one has got to be 1 minus x over 1 minus x squared plus 1 over 1 minus x squared, which gives me 1 minus x plus 1 over 1 minus x squared, which gives me, just a bit of tidying up, 2 minus x over 1 minus x squared. Is that in the form that we wanted? A minus x over b minus x all squared. Yes, it is. I'm happy then that a is 2 and b is 1. Okay, so moving on. Question 4. Detailed reasoning. Solve the equation 3 sine to the power of 4 plus sine squared equals 4. First job, that looks like a hidden quadratic. So let's solve the hidden quadratic. We are going to say 3 sine to the 4 theta plus sine squared theta minus 4 equals 0. Again, it says detailed reasoning, so you shouldn't be sitting there just plugging it into the calculator and using the answer, but there's nothing stopping you popping it into your solver to do the factorising for you. So this is polynomial order 2. We have got 3, we got 1, and we've got minus 4. That then gives me sine squared phi. If that's positive 1, this needs to be minus 1 as one of my brackets. And then I'm going to have 3 sine squared, oops, not theta, sine squared phi plus 4 equals 0. Nothing's stopping me doing that. The examiner can't prove that you didn't do that you didn't just factorise it in your head. They have to assume that you did. So what can we have there? From that, we can use the solutions that we had. So therefore, sine squared phi is 1, or sine squared phi is minus 4/3. Again, detailed reasoning, so I'm going to reject this right-hand one. There are no real solutions because we're about to try and do a square root. So that therefore means sine phi is 1, or sine phi is minus 1. We're going between 0 and 2 pi. Make sure your calculator is in radians. Mine is. You can see I've got the R in the corner. You should know already that if you've got sine just from its graph, if we've got that and we're going between 0 and 2 pi, the only place that you get 1 in that is at 90 degrees. So from that first one, that's 90 degrees or pi over 2. Again, double check that if you're not sure. So inverse sine of 1 straight away gives me half pi. And then we can do the other one. Phi is minus 1, so that's 270. So that is 3 pi over 2. That's question 4 done. So, what have we got? We're going to question 5. This is a horrible looking proof question. Determine the set of values of n for which n squared minus 1 over 2, n squared plus 1 over 2 are positive integers. Right, they've got to be integers. So we're dividing them by 2 and getting positive integers. So therefore, n squared minus 1 and n squared plus 1 have to be even. So if that's the case, that means n has to be odd. So therefore n is odd. Okay? Because if n squared minus 1 over 2 is an integer, so it means I've divided it by 2 and got a whole number. That means the original number had to be even, so that's why your n squared minus 1, n squared plus 1 have to be even. If you're adding or subtracting minus 1 to get an even number, you had to have an odd number in the first place. So that means that n squared is odd, and you get square odd numbers from squaring odd numbers. 1 squared is 1, 3 squared is 9, 5 squared is 25, and so on. So, what can we say then? We are going to say that, so n is odd. We can say that n squared minus 1 over 2 is greater than 0. So we can do multiply by 2. We can say n squared minus 1 is greater than 0. So n squared is greater than 1. So n is greater than 1. So that's on the first one. We can have check the other one. So n squared plus 1 over 2 is greater than 0. So I'm going to get n squared is greater than minus 1. I'm going to get no real solutions for that. That's not worth it. So, not a fan of that. So n is a positive integer. So assuming n is a positive integer, that therefore means n has to be an odd number greater than 1. If you make it such that n squared doesn't have to be a positive integer, just that it has to be positive. Right, it doesn't even have to be positive because you can square it. You could also do the same thing, and you could say that n has to be the root of the odd integers bigger tn 1, because you could have root 3 would work in there, because you would get 1, you would get 5. That would work. So you could do it that way, but I think the easiest way to do it is to assume that n is a positive integer. And you are absolutely fine doing it either way. So then goes on to talk about a Pythagorean triple is a set of 3 positive integers such that prove that for the set of values in there, the numbers n squared minus 1 over 2 and n squared plus 1 over 2 form a Pythagorean triple. So that is going to be, well, we know if it's a Pythagorean triple, a squared plus b squared equals c squared. So Pythagoras tells us, and we know this, we're really familiar, that if you square the 2 short sides and add them up, you will get the long side squared. So n squared minus 1, let's pop some numbers in to see which is the smallest. Let's make n 3, for example. So n is 3, so that's one side. N squared minus 1 over 2. So 3 squared is 9 minus 1 is 8 over 2 is 4. So that's 3, 4. And then I'm going to get the 3 squared is going to be 3 squared. I'm going to get 3 squared plus 1 is 10 over 2, 5. That's 3, 4, 5. So the n squared plus 1 over 2 is going to be the longest one. So if this works, if this is going to be a Pythagorean triple, we should be able to do n squared plus n squared minus 1 over 2 all squared is going to be equal to n squared plus 1 over 2 squared. So let's try that. So n squared and n squared minus 1 over 2 are the shortest sides. So therefore we're going to say, oops, that first one's not n squared, that's just n. So we are going to say n squared plus n squared minus 1 over 2. That's n squared. That needs to be squared. Then I'm going to square this, so that's going to be over 4. I'm going to have n to the 4 minus 2n squared plus 1. Then if I want to add these up, the left-hand one needs to be over 4. So that's 4n squared plus n to the 4 minus 2n squared plus 1 over 4, which is n to the 4 plus 2n squared plus 1 over 4. Then we may as well go and factorise from this side. That top is going to be n squared plus 1 squared. The bottom, 4, is 2 squared, which is n squared plus 1 over 2 all squared. Whoops, my writing, I wasn't paying attention, my writing's gone off screen. So we get down to that stage. Should always have a conclusion. This proves that. For previous n squared minus 1 over 2, n squared plus 1 over 2 form a Pythagorean triple. Right, that was a vile question. Right, prove. This feels a bit nicer. Prove that 2 cos 2 theta plus 45 equals cos squared minus 2 sine theta cos theta minus sine squared theta. Right, so let's work from the left-hand side. And I think the first place to start is, I know we need to get to cos thetas and sine thetas. We've got 2 thetas to start with, but let's deal with the fact we have compound angles in there. So let's go and grab our cos compound angle. So from the formula book, we are going to go top of the second page. We've got cos of A plus or minus B is cos A cos B minus plus sine A sine B. Alright, let's go back to where we were. And we've got that. So we've got root 2 is just going to sit outside. So we've got cos A, so that's cos 2 theta cos 45. This is plus, so we need minus sine 2 theta sine 45. Still got a root 2 outside, not dealt with that. Cos 45, let's just double that, so we're in degrees, so I do need to change the calculator into degrees. Angle output, degrees, and then we'll do cos 45. Should remember it, it's root 2 over 2. So I'm going to get root 2 over 2 cos 2 theta minus, and sine 45 is the same, root 2 over 2 sine 2 theta. Let's start expanding that bracket. So root 2 times root 2 over 2, or root 2 times root 2 is 2, over 2 is 1. So I'm just going to get rid of the root 2 bits. I'm just going to get cos 2 theta minus sine 2 theta. Now we need to start looking at our cos 2 theta, and our sine 2 theta. So what have we got? Well, let's go back and get the formula for sine A plus B. Just make sure that we've got that to hand. So sine A plus B is sine A cos B plus minus cos A sine B. So back onto our question. Right, cos 2 theta then. So again, going off in the corner. So cos 2 theta, we're going to use a double angle formula and make A both of them. So I'm going to have cos A, so that's cos squared A, or cos squared theta. We've still got minus, and then it's sine A, so that's sine squared theta. Well, that's convenient. I do need a cos squared theta and a sine squared theta. Let's go for sine A plus B and make that into the 2 theta. So sine 2 theta is sine A cos A plus cos A sine A, or 2 sine theta cos theta. So let's pop these in. So cos theta, cos squared theta minus sine squared theta. Whoops, not minus, that's a plus 2 sine theta cos theta, which is cos squared theta plus 2 sine theta cos theta minus sine squared theta, which is what we wanted. Let's move it on. Question 7. There's a lot of words in this one. It's vectors. So A and B are fixed points in the plane. The position vectors of A and B are A and B respectively. So state with reference to the points A and B the geometrical significance of the quantity mod A minus B. So let's have a quick see what we got. So I've got A, which is there, and I've got B, which is there. There's my vector A, and there's my vector B. So what happens if I so we do minus B plus A. Start at B and go backwards along B and then forwards along A. Gets me to there. So that is the same as doing that vector. So that there is A minus B. So the modulus bit is just talking about making it a length. So this is the length of AB. I'm going to put a vector on it. So that's A and that's B. What have we got? A half of A plus B. Right, let's get rid of I didn't want to get rid of the red line. So a half of A plus B. So let's pop in a different colour. We're going to do A, and then can I copy B and see what that looks like at the end of it? Copy that and paste that. So if I paste that, we get along there. So that's A plus B. if I want to go half of that, that looks suspiciously to me like we are going to go. So if that's the line A plus B, half of that looks suspiciously like it's just going to go halfway along the line there, which we had that line A plus B. Yeah, that would make sense to me. So that is halfway, sorry, the midpoint of that line AB. Right, so what have we got? We haven't done very much about circles usually. This feels more like a further maths question when we start talking about circles on there. So, the circle P is a set of points with position vector P in the xy plane which satisfy P minus half A plus B. So what this is saying, so we've got the modulus around that, so that is saying the length of the vector that goes between P and that half A plus B. So that tells me that the centre of my circle is at half A plus B. So the centre of circle is half A plus B because of that first bit there. So I have a random point and I want to know how far away it is from that point. It is then half of the distance A minus B. So that suggests to me that we've got this circle and its radius is a half A minus B. For 1 mark, that feels unfair for on a maths paper. It would feel absolutely fine on a further maths paper. But there we go. It was on there in 2020. It is now given that A is 2, 1, B is 4, 5, and P is xy. So let's have a look at that then. Find a Cartesian equation of P. So we want our centre of the circle, which we know is half A plus B. So what we got, centre is half A plus B, which is a half of 2 minus 1 plus 4, 5. So that's a half. 2 plus 4 is 6. Minus 1 plus 5 is 4, which is 3, 2. So my centre is 3, 2. My radius, I said, was a half, the modulus of a half A minus B. So that is half A is 2 minus 1. B is 4, 5. So that is a half. The modulus of 2 minus 4 is minus 2. Minus 1 minus 5 minus 6, which is a half of have I done that right? So minus, let's work this out. The modulus then is going to be the root minus 2 squared plus minus 6 squared, which is a half. Let's just check that out. Half of root, let's get rid of the minuses, 2 squared 6 squared is root 10. And that is r. So if I've got a centre and I've got a radius, therefore my circle x minus 3 squared plus y minus 2 squared is equal to 10, because I'm going to square that root 10. Okay, so we have got question 8. Question 8 is the rate of change that says implies differentiation. A certain population at time t is modelled by the equation dp by t. So we've already got that. It's 100 minus p, and we initially know that p is 200. Determine an expression of p in terms of t. Describe how the population changes over time. Well, differential equation time. So we want to get everything with a p onto the left, everything with a t onto the right. So 1 over 100 minus p dp integral is equal to integral dt. Let's deal with the left-hand side first, because the right-hand side's easy. That's t plus c. The left-hand side then, let's see. Let's make u equal to 100 minus p. So I'm going to use some substitution just to make sure I get all my signs right. So du by dp is minus 1. So therefore, minus du is equal to dp. So we can therefore say the integral of 1 over 100 minus p dp is minus the integral of 1 over u du, which is minus ln 100 minus p. Not going to worry about the plus c because I'm going to put it on the other side. So therefore, if we continue on with our working, we can go back to the statement. So the integral of dp is equal to the integral dt. So we know that was minus ln of 100 minus p is equal to t plus c. We can then say, take the minus across, so ln 100 minus p is equal to minus t plus c. I'm not worried about the sign on the plus c, that should come out in the wash. Let's take e, so raise these to e, so 100 minus p is a e to the minus t. That's a standard result that you can use, so that p is therefore 100 minus a e to the minus t. We have some boundary conditions. We are told initially p equals 2000. So initially, knowing that word then, initially that means t equals 0 and p is 2000. Let's pop those in. So 2000 is 100 minus a e to the 0. So 2000 is 100 minus a. So let's just double check that. 100, that'd be 100 minus 2000. So a is minus 1900. So therefore, our final solution then, therefore p is 100 minus 1900 e to the minus t, 100 plus 1900 e to the minus t. So that is p in terms of t. Describe how the population changes over time. So what do we know? we know initially P is 2000. Because we've got that negative exponential, that follows the same path as every other negative exponential. So that is going to get smaller. So the graph of a negative exponential looks like that. So we know it's going to decrease. And then we know as t gets massive, e to the minus t gets really, really small, almost zero. So this 1900 e to the minus t is going to disappear, and we are going to approach 100 in the long term. Approach 100. I've put the word 100 in there. Approach 100 in the long term. Okay, so the limit is 100. It's got an asymptote at y equals 100. Right, so what are we on to now? I think we're on to the stats portion. Histogram shows information about the number of cars in 5 different price ranges sold in 1 year at a car showroom. 66 cars in the price range 10,000 to 20,000 were sold. So we know there are 66 in there. We are given a frequency density, which is on the scale. Let's see, I like doing this with squares. I'm not going to worry about frequency density. So how many squares have we got? 25, 50, 75, 100, 125, 150, 165. So 165 squares is equal to 66. That's not very nice. Let's see what happens if I find out what 1 square is. So 66 divided by 165 is 2/5. So 1 square is 2/5 of a car. So every 5 squares is 2 cars. That's useful information to us. Find the number of cars sold in the price range 50,000 to 90,000. So that is this big blob here, every 5 squares. So 25, 50, 75, 100, 125, 150, 175, 200. So 200 squares. So if there's 200 squares, every 5 of those is 2 cars. So 200 divided by 5 times 2 is 80 cars. So there are 80 cars. Let's just move the working out to a more appropriate place. 200 squares state the units of the frequency density. Well, the frequency density is the area. No, it's not. The frequency is the area. So the frequency density is going to be frequency per price. So that is frequency per pound, because it's in pounds. Suggests one change management could make to the diagram so that it would provide more information. Well, you've got a massive blob in this last area, so let's make that. So put more class bounds. So something like break up. The 50,000 to 90,000 block. Something about you want smaller intervals. So we want to find out, estimate the number of cars sold in the range 50,000 to 60,000. We've got 25, 50 squares. So 50 squares, that happens to be a quarter of what we had before. So 50 squares is going to be 20 cars. Now, that was a pretty decent stats question to start with. Pierre is a chef. 7 marks, that's probably a hypothesis test. What are we doing then? Pierre claims that 90% of his customers are satisfied with his cooking. Yvette suspects that Pierre is overconfident about the level of satisfaction amongst his customers. She talks to a random sample of 15 and finds that 11 say they are satisfied. She performs a hypothesis test. Carry out the test at the 5% significance level. So, I reckon this is a binomial hypothesis test because we know how many people are being asked, and it would imply that we have a fixed level of fixed probability. So let's do this. Let's say we're doing binomial, so we're saying x is distributed binomially. We've got 15 people, and we've got p is 0.9, and again, p is the proportion of satisfied, proportion of satisfied customers. Always need to define what P is. So we need to define a null hypothesis. So that's where we think that everything is as he thinks it is. So that is that P is 0.9. And then we need to do our alternative hypothesis where we see what she thinks. She thinks he's overconfident. So that means that fewer people think that. So P is less than 0.9. So what are we going to do? She finds 11 say they are satisfied. So we want to find the probability that X is, what do we need? We need to find the probability that X, if we're over-satisfying, she reckons not many people, so that X is less than or equal to 11, because we're going with what she thinks, or a worst case scenario, and a worst case for Pierre is that fewer than 11 would do that. So that we can just pull straight from the calculator. So we go to our calculator, we go to our distributions, binomial CD, Px is less than or equal to 11 is what it will give us. So we pop 11 in, 15 and 0.9. That gives me then the probability of that is 0.0556 to 3 significant figures. If we compare that with our 0.05, which is the 5% significance level, that is bigger than 0.05. So we will not reject. We are not going to reject our null hypothesis because we are bigger. There is not enough evidence to suggest that Pierre is overconfident That's a really easy 7 marks. Making sure we define what P is. So 1, 2, 3, 4, 5, 6, and 7. Nice, easy 7 marks. Question 11. As part of a research project, the masses of a random sample of 1,000 pebbles from a certain beach were recorded. The results were summarised in the table. Calculate estimates of the mean and standard deviation of these masses. 2 marks. Don't even think about doing it by hand. You are going to go straight into your statistics mode. And this is one variable. Oops, I don't have my second column on, so make sure you've got that. So shift setup. We want to have the statistics mode and turn the frequency on. So we want estimates, so we need to find the midpoints. So we should be going, so this is up to 150. We are including 50, so this is going to be, I need to have my class widths in here, so that's 49.5, because this is continuous data, plus up to, but not including 150, so that's 149.5 divided by 2. I am going to have same again, so 149.5 plus, what's that going to be, 199.5, because we're not including it, divided by 2. 199.5 plus 249.5 divided by 2. And then last one, we've got 249.5 plus 349.5 divided by 2. Right, got all my midpoints in. Let's go and change the frequencies. So 1, 6, 2, 3, 1, 8, 3, 5, 5, 1, 6, 5. Right, clear that off, and we're going to go OPTN, and I want my calculations. So I can get my mean X bar is 200.725. So X bar is 200.725. Which is 201 to 3 sig figs. And my standard deviation, is 60.7. So it's that one there. Sigma X standard deviation is 60.7 to 3 sig figs. Right. Proposed, we're going to use this. Random sample of 1,000 pebbles were also found. We're going to use a normal distribution, find the model to find the probability that we are between 150 and 210. So I need to go back into my calculator and clear this off first, back into distribution, and I go normal CD. So my lower is 150, my upper is 210, my standard deviation is root 3,600, and I'm sure a proper statistician will tell me why we don't put the standard deviation in the distribution. And my mean is 200. And that gives me a probability of 0.364. Right, what are we going for? Use the model to determine x1 such that the probability between 160 and x1 is 0.6, giving your answer correct to 5 significant figures. Right, okay. What do we know about this? Well, let's draw some normal distributions. we've got 200 there, and we are between 160, which is going to be somewhere about there, and the other one is going to be bigger than 200 because that area there is greater than a half. So even if it was minus infinity to x1, it would still be past 200. So I'm going to say that's there. So that is 160 on the left, and that is x1. I think it would be a good idea to find out what that is on the left-hand side. So this green area here, we can go back into our distributions. Oops, wrong one. We can go back into our distributions. We want the inverse normal. And this time I am going to say that I don't want an inverse normal. I don't have an area. I want to find, that's fine, go away. I want to find what the probability is of that green one. That's normal CD. So my lower, let's make it really small, minus 99999. My upper then is 160. And that tells me then that my green area there is 0.252. 252, yeah, 0.252. So then that means that the whole area that I'm interested in, that I'm just going to shade yellow, that whole area, so therefore the probability that x is less than x1 is 0.852. So therefore I'm going to do the inverse normal of 0.852, and that's going to give me x1. So that's what I was after here. So the inverse normal of that, so menu, distribution, inverse normal is 3. My area is 0.852. Keeping the same standard deviation, keeping the same mean, gives me that x1 is 262.7. So to 3 sig figs is 263. Oh, to 5 significant figures. I am going to go for, let's put a few more decimal places onto this area then, because let's see what we're going for. Right, go back and find that 0.252. We're going to, so we want that, normal CD, yeah, that's fine, and that gives me 0.252, so that'll be 85249. 4925283. May as well use them all. 25283. So let's go back onto our distribution, inverse normal, and that's going to be 0.85249 25283 262, and we're going to correct to 5 significant figures. This is 262.83. 262.83. It is found that the smallest and largest of the pebbles were 112 and 288. Use these results to show the model may not be appropriate. So this is where we are looking at upper and lower bounds of normal distribution. So with our current model, all the data should be within plus or minus 3 standard deviations. So if we do, from the mean, sorry, if we do the mean, which is 200, plus 3 times 60, that's going to be, I think that's 380, but let's just double check. So 200 plus 3 times 60 is 380. And then we're going to go the other end. So let's just double check what that's going to be. that would be 20. So 200 minus 3 times 60 is 20. So our current model suggests that we should have upper and lower. That's our standard deviation. Our biggest stone should be 380, and our lowest should be 20. So I think that is enough to say. So model suggests, let's just make a note of that. The model suggests that the biggest and smallest stones should be 380 grams and 20 grams respectively. Suggest a different value of a parameter of the model in light of these results. So let's say my upper bound is 288. So therefore 288 take away 200, well that's 88. And then I'm going to do 88 over 3. Let's just double check what that is. 88 divided by 3 is 29.3. Let's try it the other way around. So I've got 200 take away, what's the other one? 112. Pretty sure that's the same thing. Is 88. So it suggests then my standard deviation should be about about 30. In the past, the time for Jeff's journey had mean 45.7 and standard deviation 5.6. This year he's trying a new route. In order to test whether the new route has reduced his journey time, he finds the mean time for a random sample of 30 journeys using the new route. People in maths questions need to get a life. He carries out a hypothesis test at the 2.5% significance level. They very much do. Jeff assumes that for the new route, the journey has a normal distribution with standard deviation of 5.6. State null and alternative hypotheses for the test. So, what are we looking at? A null hypothesis. Mu is 45.7. Alternative, what's he trying to do? Whether it's reduce his time, so mu is less than 45.7. Determine the rejection region for this test. So we have got to find out what our distribution is. So x bar distributed normally with mean of 45.7, and then we've got, what's the standard deviation? 5.6 squared over 30. We want a probability, a rejection region, so we're trying to find times that are low enough such that they have, so this is normal, so we've got that. We're suggesting that's 45.7, and we want to find an area, we want to find this region down here such that that probability is 0.025, and this is going to be, let's call that x. So we are trying to find, oops, put back the red pen, the probability that x is less than x is 0.025. So let's go for the old normal distribution. So back to our normal distribution. Inverse normal. Area is 0.025. Sigma is 5.6 divided by root 30. And mu is 45.7. So that tells me then my rejection region is 43.7. Rejection doesn't feel right here because he kind of wants it to be less than that, but his rejection region is a time less than 43.7. Okay, so what are we going for now? We are looking at Andy and Bev. They are playing a game. Game consists of 3 points. The probability Andy wins is 0.4 and Bev wins is 0.6. If one player wins 2 consecutive, they win the game. Otherwise, neither player wins. Determine the probability of the following events. Andy wins the game. Now, my initial thinking is that this is going to be 0.4 times 0.4, but I don't think that's the case. So, what ways could happen? So, let's do a little tree diagram. So, I could have A and B, A and B, A and B. So, I've got AA, that would win. So I would have no more options after AA. I've got A and B there, which would actually be a win for B. I've got B, A, and that would be A and B, which would be a win for A. And then I've got BB, which is a win for Bev. So the probability Andy wins is probability of A plus the probability of B A. That's 0.4 squared plus 0.6 times 0.4 squared, and that's going to be, so I've got 0.4 squared plus 0.6 times 0.4 squared is 32 over 125. Right, the probability that neither player wins the game, so that was A, B, A. Oh, it consists of 3 points, so it can't go longer than that. Okay, I didn't read that bit. So A, B, A, B, A, B. So you've got probability of neither is the probability of it going A, B, A, plus the probability of it going B, A, B. So that's 0.4 squared times 0.6, and that's 0.6 squared times 0.4. Let's go for, let's reuse some of this. So that 0.6 times 0.4 squared, let's turn that into a 0.6 times 0.4, 6 over 25. or 0.24. Right, Andy and Bev now decide to play a match which consists of a series of games. In each game, if a player wins the game, they win the match. If neither player wins the game, they play another game. Determine the probability that Andy wins the match. 3 marks. So we're playing till we get a winner. So what could happen? We get the probability that, let's have a look. So we could either have the probability that Andy wins. Well, he could win the first time. So if he wins, that is the probability of Andy, which is your 0.4 squared, which is, let's just double check. So the probability he wins is 32 over. So the probability, we're going to use all the numbers that we've had. Okay, so this is the probability that Andy wins match. Andy wins the game, rather. Which is what we worked out previously. So we could do it the first time, plus the probability of neither times the probability Andy wins the game, plus the probability of neither times the probability of neither times the probability of A. This is a geometric sequence. So A is the probability that Andy wins that we had before, and my ratio is the probability that neither of them win. And because R is less than 1, this is an infinite series. So S infinite is A over 1 minus R. The probability that Andy wins is 32 over 125 over 1 minus 6 over 25. So we have got 32 over 125 over 1 minus 6 over 25, which is 32 over 95. And you can give that as decimals you wanted. If you wanted 0.337 to 3 sig figs. Question 14. Large data set. Table shows the number of usual residents in the age range 0 to 4 in the local authorities, in 15 of them. In 2001 and 2011, the table also shows the increase in the numbers in the age group and the same increase as a percentage. Lovely. You've got a graph showing the increase in LA in raw numbers and then a percentage increase. Okay. What we're asking, the education committees in these local authorities need to plan for the provision of schools for pupils in their districts. Explain why in this context the increase is more important than the actual numbers. Because we need to know how many actual chairs, how many actual extra school places we need to find. Okay, we already have chairs for the existing people. We need school places for all these new people. So I think I'd write something like that. So we need school places for all the new people. Need places for the extra people. We already have places for the existing people. In which of the following LAs was there likely to be the greatest need for extra teachers in the year 2011? Bolton, Sefton, Tameside, or Wigan? Right, let's have a look. We don't want percentage, we want that. So we've got Bolton, Sefton, Tameside, or Wigan. Let's have a look. Let's highlight those. So Bolton, Sefton, Tameside, or Wigan. Wigan, just. Wigan, greatest increase in population. State an assumption about the populations made to make your answer valid. Populations grow at the same rate. Populations grow at the same rate. In 2 of the 15 LAs, the proportion of young families is greater than the other 13. Suggest using only data from Figure 2 and Figure 1 and or Table 1 which 2 LAs these are most likely to be. Manchester has had a high increase of percentage of people and a high increase overall. So they've had the highest percentage increase. So it's probably those. So Manchester, and probably Salford. They have the highest percentage increase. Right, I think we've got one last question. That would be question 15. My favourite, probability distribution. So, we have that. So the probability that x is 2 is 15 over 32. Let's see what the way to do that is. So, probability x equals x is 15 over 64 times 2 to the x over x factorial. So therefore the probability that x is 2 is 15 over 64 times 2 squared over 2 factorial. I bet you that's going to give me 15 over 32. So let's try 15 over 64 times 2 squared over 2 factorial. Look at that, that's 15 over 32. Right, values of 3 independent observations of x are given by x1, x2 and x3. Given that the sum of x1 plus x2 plus x3 is 9, determine the probability that at least one of these 3 values is equal to 2. So the word given, that tells me we've got conditional probability. Let's just find the distribution first. We haven't done that yet. So let's find the probability. Let's find values of x, and then the probability that x equals x. And we've got 2, 3, 4, and 5. Yeah, that's 15 over 32. We want to have, that's a 3, and that's a 3. That's 5 over 16. And we want, that's a 4. And that's a 4, so that's 5 over 32. Again. Oh, it was 15 over 32 before. 5 over 32, and then we've got, that's 5 factorial, and that's a 5 there, 1 over 16. Right, we are trying to find out the probability at least one value is 2, given that x1 plus x2 plus x3 is 9. So how could I get 9 out of those? I could have so we could do this by doing a 2, a 2 and a 5. I could do 2, a 3 and a 4. And I could do 3, 3 and 3 in any order. So let's find the probabilities of each of those. So 2, 2 and 2 is going to be 15 over 32 times 15 over 32 times 1 over 16. And then there are 3 ways that that could happen. 2, 3, 4 is going to be 15 over 32 times 5 over 16 times 5 over 32, and then I could move the 4 into any of the places, and then I can have the 3, there are 2 spaces left for the 3, so that means there are 6 ways of doing that. And then there's just the one way of doing the last one, which is 5 over 16 cubed. So the total then, so the probability that x1 plus x2 plus x3 is 9 is, let's work that out then. So we have got 3 times 15 over 32 times 15 over 32 times 1 over 16 plus 6 times 15 over 32 times 5 over 16 times 5 over 32 plus, let's just do this cubed, 5 over 16, not squared, cubed. And the probability that I'm going to get the sum of that to be 9, that's 3, 4, 2, 5 over 1, 6, 3, 8, 4, which is 0.209. Let's keep that to hand then. So what's the probability? Let's look for, this is a given that. So let's look for, let's go back to our formula sheet and find the formula for the given that. Probability is this one here, P8, let's make a note of that, A given B is the probability of A and B over the probability of B. So probability that at least one value is 2 and the probability is 9. So let's do that then. Probability at least one value equals 2 and x1 plus x2 plus x3 equals 9 is, it's going to be, the probability is going to be those first two rows added up. So I can just get rid of, in my calculator, this. That should give me that, which is 2925 over 16384, which is 0.1785. So then the probability that what we want, at least one value is 2. Given that x1 plus x2 plus x3 is 9, is going to be 2925 over 16384 over 3425 over 16384. They're going to cancel. So I am going to get, let's just divide the answer we've just got, which is the 2925, divided by 3425 over 16384, which is 117 over 137, which is 0.854. Frida chooses values of x at random until she's obtained x equals 2 exactly 3 times. She then stops. Determine the probability she chooses exactly 10 values of x. Right. Determine the value of probability she chooses exactly 10 values. So that means that the 10th number has to be 2. Because that's the only way that she would stop. So that means she's have 9 values of 2 and getting, she's picking 9 values and getting 2 2's in there. So that's become a binomial distribution. So let's make it y this time. So y is a binomial. She's doing it 9 times, and this probability of picking a 2, the success, is 15 over 32. We've done that already. 15 over 32. We need exactly two 2's in there, so the probability that y equals 2 is going to be, so that's a binomial. Let's do that from the calculator. So that is going to be binomial. No, I just want a binomial PD. X is going to be 2. N is going to be 9. And my probability is 15 over 32. And that gives me, that's a probability of 0.94466464991. So therefore the probability that x is 10, if that's my number of goes, is going to be 0.0945, which is the probability that I got 2 9s in the preceding 9, plus the probability of getting a 2, probability of getting 2 2s in the preceding 9, and then a 2 is my 10th digit, so that's 15 over 32 again. So I can then go back to menu. I can do my answer, just check that that's what it is. Yep, multiply by 15 over 32, which gives me 0.0443. And that's it. That's October 2020, paper 2 done. As ever, like a real YouTuber, like, share, and subscribe.